Hi everyone, it's Jackie. If you've been following with me for a while, long time no see. Sorry to not do the October, November predictions, but I'm here for December, so that's what matters. So in today's video, I will be telling you the math predictions that I think you will be seeing, if not the same, very similar questions on your December SAT. So like, rate, and subscribe if you like the video, and per usual, we will jump in. So first thing I want to cover is functions. I am going to do a few problems with functions. I find that these appear on every single SAT exam. Students always report that they felt the functions are really difficult, but they don't have to be. So let's make them easy. So I'm going to show two ways. I'm going to show you how to solve on Desmos and also algebraically for those that like to see the math and handwritten arithmetic behind it. So let's begin. Okay, so here I think you will be seeing something similar to this on December 2025 SAT. So it says the function h is defined by h of x is equal to ax plus b, where a and b are positive constants. The graph of y equals h of x in the xy plane passes through the points 0, 10 and 2, 13. What is the value of ab? So whenever I am provided with two coordinates, we can definitely create a table on Desmos. So let's go ahead and do that. Okay, so we are here on Desmos. I have my question here. So what I want to do, whenever you have points, we can create a table. So I go here to table, or alternatively, what I personally like to do is type in table, and the table appears. Now I will punch in our data. So we have 0, 10, and 2, 13. And next I'm going to put in this equation, but I'm going to put it in as a regression with a tilde. So I use y1, so it's going to read all the data points from this column. And then we're not going to use equal, we are going to use the tilde symbol, which is here. And then I'm going to put a, and note I'm going to put a to the x1. So it's going to take the values here in the x1 column, and then I just put plus b. And with that, that's all I have to do. Look, it tells me that the value of a is 2 and b is 19. So I know that the value of a times b will be 2 times 9, which is correct answer 18. And that's the answer. Isn't that amazing? So just remember when you are doing a regression with Desmos, basically when you're using the tilde symbol, it's telling us to find values for the parameters that make the function that's going to best match the points that we've put into the table. And that's amazing, isn't it? Okay, and for those that are curious about how you would solve this algebraically, let's say there was a Desmos blackout, what you can do is you take our equation provided, h of x is equal to a to the x power plus b. We are provided with two coordinates, so I can use these. And notice the problem says where a and b are positive constants, so interesting. So I have 0, 10, then I just plug the 10 in for the y value, a, x for the 0, plus b, anything raised to the 0 power, it's always going to be 1. So I know that this is going to be 10 is equal to 1 plus b. And then we get that 9 is equal to b. And then now I do the same with our coordinates to 13. I'm going to go ahead and plug them into our equation. Let's go do that. So I'd have 13 is equal to a squared plus b. But now I know what b is from our previous solving, so now I can substitute that in. So 13 is equal to a squared plus 9. Next, I can subtract 9 from each side. So I get that 4 is equal to a squared, and then we take the square root, and I get that 2 is equal to a. And just as we saw with Desmos, our a value is 2, b value is 9, 2 times 9 is 18. So pretty quick to solve algebraically as well. Both ways are amazing. Know how to do this for the exam. I feel that you'll have something similar in December. Continuing our journey. Next function. Ooh, yikes, looks intense. So here we have f of x is equal to 3/8 x minus 3/2 cubed plus ax squared divided by 4 plus bx divided by 4 plus c divided by 4 plus 99/2. If the x-coordinate of the x-intercept of the given function f is at x equals 4. So remember, x-intercept is where y is equal to 0, x equals 4, x equals 12, and x equals -2. What is the value of 16a plus b plus c? Okay, so this one definitely would get messy algebraically, but we can solve it, I think, in under 2 minutes for sure, maybe even a minute on Desmos. So again, we do have coordinates provided to us. It tells us the x-intercept. So that would be for all of these, x is equal to 4, the y value will be 0. So let's go ahead and type that into our table. And um, that would be x is 4, 0, 12, 0, -2, 0. And then next, just like we did in the previous question, I'm going to make a regression with the equation provided here. So let's go ahead and do that. Remember, we're going to type in y1. It pulls from all the values here. Then I use the tilde symbol so that I can get the parameters of the expression. And then I'm going to start typing. Let's go ahead and do that. So you can see I typed in everything amazingly here. We have everything typed in. I have my A value, the B value, the C value. And note we're asked for what is 16A plus B plus C. So all you have to do now is use 16 and then type in A plus B plus C and it will pull from it. And it gives us the answer, which is -789. And that's what I would type into our answer sheet. Wasn't that amazing? Personally, if I got a question like that on SAT, it was so quick to solve in Desmos, and the algebraic way does take probably over 2 minutes. So I would just do that and do that for the exam. If you want me to solve it algebraically, let me know in the comments, and I'm more than happy to do so. Okay, now another function. And guys, I hope if you're solving these, pause the video, see if you can solve them, and then see if my answer matches yours. So here we have the function f is defined as f of x is equal to -x cubed minus ax squared minus bx minus c, where a, b, and c are integer constants. The zeros of the function are -9, -4, and 5. What is the value of a plus b? So this one too, I would say, is another great one to solve in Desmos. So we can see once again, I would type in our table and then it tells me where the zeros are at. So what that means when we're plotting is that the zeros would be when um, it gives us the x values and the y's would be at 0. So I have -9, 0, -4, 0, and then 5, 0. Now we have the data from the table. Now I can create the equation provided and we do y1. Then I go ahead, I type in the tilde symbol, and then we're going to put -x1. Remember, we have to put in the 1 to pull from our table here. Put -1x cubed, and then minus ax1 squared, and then minus bx1, and then minus c. And we can see I have all my values, a, b, and c. I'm asked for the value of a plus b, and we just type in a plus b, and I get that it's -21, and that is the correct answer. You see how quick and easy these are in Desmos. So if you get a function on your December SAT, which I do think you will have something similar to these ones, perhaps not all three of them, but at least one of these ones that are quite similar. Um, I'm solving these in what, under a minute, right, with Desmos? So be sure you feel comfortable with these. Since I said I would do it algebraically, I mean, this one definitely I would just use on Desmos as well. But just to show, so since we are told the zeros of the function are what the roots are. So another way to express that would be like this is x plus 9, x plus 4, and x minus 5. This is before we applied the negative in front. So if we look at it, it's like this with a negative sign. Okay, so then what can we do? Then we can factor out and expand. So first I would expand these two here. So this would be x squared plus 4x plus 9x, so plus 13x plus 36. Now we have to multiply this expression by x minus 5. So when you're doing this, just to show, like to keep it simple, you can be like, all right, so this is going to be x squared, x minus 5. Like keep the terms separate. That'd be plus 13x, x minus 5. And then we would have plus 36 and x minus 5. And then we can distribute accordingly and simplify to get what our answer is. Let's see what that gets. So this would be x cubed minus 5x squared. Then we would have plus 13x squared minus 65x. And then we would have plus 36x and then minus 180. Now I'm going to like combine all of our terms and see what it simplifies to. And there's only one x cubed, so x cubed stays the same. Combining our x squares, that will be plus 8x squared simplifies to. Then we would have minus 29x, and then we have minus 180. Or we still haven't applied the negative sign at the beginning, so now I'm going to do that. We basically will distribute that to each term. So then we would have negative x cubed minus 8x squared plus 29x, and then plus 180. And then we just start comparing this to our expression above. So I can see that negative 8 would correlate to, so basically like negative 8 is equal to negative a, so therefore 8 is going to be equal to a. Likewise, 29 is going to be equal to negative b, so negative b is equal to 29, so b is equal to negative 29. And well, if we want to get c would be correlating, negative c equals 180. But we're only asked for the value of a plus b, and then all we have to do is do a plus b, which is going to be 8 plus negative 29, which gives us to the correct answer that we solved earlier on Desmos, negative 21. So that's how you do it algebraically. As you see, perhaps Desmos was a little bit quicker. So next up we have this one. Looks pretty crazy, but no worries, because guess what we can do again? Oh my goodness. We are provided. Well, let's read it. It says the function p of x is defined as p of x is equal to a multiplied by x plus 6 squared minus b multiplied by x plus 6 squared minus c, where a and b and c are constants. In the xy plane, the graph of y equals p of x passes through the points negative 724 and 0, 899. What is the value of p of negative 12 plus p of negative 5? So let's see. So also, I would take this over to, oh my goodness, yes, we can use Desmos again. So use Desmos as your tool, guys, to really help you with the function. Okay, so once again, we have a table, and I'm going to type in our provided coordinates. So we have negative 7, 24, and we have 0, 899. Next, we are going to make a regression so that um, the equation will pull the parameters and we'll get values for a, b, and c. So let's go ahead and do that. So we have y1 tilde, and then we have a, and then we have x1 plus 6, and that's squared, and then that's going to be minus b. Amazing. And then I'm going to type in x1 again, and then plus 6, and then squared, and then minus c. Okay, so I have values for A, B, and C. So now that I have those defined, what we can do is um, actually type in the equation again, but this time I'm going to type it in just as I see it here above, because now I can use equal. Why? Because this time I actually know what the parameter, or what the A is equal to, B is equal to, and what C is equal to. So let's go ahead and do that and see what happens and see if you're amazed by what happens. So then we have x plus 6 squared, and then minus c. So you see there's no sliders created because it is directly pulling from the parameters above. And then with this information, now I can directly type in for what p of negative 12 is, plus p of negative 5. And oh my goodness, that is the correct answer, 923. So you see, yet again, I can use Desmos to solve really quickly and rapidly these kind of solutions. And I encourage you to do that on the exam. So let's look at this one. So we see for the function f, for every increase of 2 in the value of x, the value of f of x increases by a factor of c, where c is a constant. Which of the following equivalent forms of the function f displays the value of c as the base or the coefficient? So basically what this is saying, like for every increase of 2 in the value of x, so when we move over 2 on the x-axis, how many times bigger does the y value get? So we can solve algebraically. However, let's look at a super Desmos hack to solve this really quickly and efficiently. Okay, so let's see here on Desmos. So what I'm going to do is type in, you can use any one of the answer choices as a guide, but I'm just going to use answer A to help Desmos see the parameters that it needs to take. So I type this in. And now I want to be like, okay, Desmos, I want to, for every increase of 2 in the value of x, so let's define what that is. So for every increase in the value of 2x, we would do f, and then I do x of 1, and I want it to increase by 2. And then I'm going to use the tilde because this is what I'm trying to determine what c is going to be equal to. So I use the regression parameter. Then we do c and fx1. And what does that equal? Oh my goodness, it's equal to 4,096. So this is telling me increases by a factor of c, where c is a constant. We need c to be increased by 4,096. And if I look at the answer choices, that seems like it will be correct choice D. Now, I didn't have to start with option choice A. I could have used B, for example, and I could do the same exact thing. So I can do f of x is equal to 43 times 8. This is giving me the parameters that I want Desmos to read to the 2 to the x. So then I'm going to say, okay, Desmos, for every increase of x plus 2, I'm trying to define what c is going to be equal to. So now I'm going to put the tilde symbol. And then again, we do c, and I put x of 1. And we can see that it is not polling correctly because I didn't put f. So that pulls f of x of 1. And you see, once again, it's going to be 4,096. So it doesn't matter which one you choose. You can choose any of the equations to help it read and be like, all right, so what's going to happen for every increase of 2 in the value of x? What happens? You might be thinking, oh, but what if I put in d? Well, let's go ahead and see, shall we? So if I do that, f of x is equal to 43, and then we have 4,096 raised to the x divided by 2. And then I want for every increase in 2, and that's going to tilde symbol of c f of x of 1, and you see it will still say at 4,096. So it doesn't really matter. For every increase of 2, it's always going to stay at c as a constant of 6 or 4,096, and that's going to be our answer. Okay, so amazing way and shortcut hack to solve these type of problems. You've probably seen them before if you've been preparing a lot of the Bluebook exams, or if you've watched previous videos of mine. So make sure you know how to do this. Amazing. Okay, next up, after functions, I think you should definitely feel comfortable with some geometry and trig problems. Okay, so this one we have in the figure shown, a is less than b if cosine 4 of a is equal to sine 2 of b. What is the value of a? Okay, so, well, first things first, what we would want to do is try to find what angles a plus b would be equal to. So let's go ahead and do that. So we know a triangle has 180 degrees, so we can say 143 plus a plus b is equal to 180. Subtract 143 from each side, and we get that a plus b is going to be equal to 37. Okay, so that's interesting. Likewise, I can rearrange this in terms of b and say that b is equal to 37 minus a. Okay, important trigonomic identity. So the sine of some angle is always equal to cosine 90 minus some angle. And that's an important identity because here they tell us that cosine of 4 is equal to sine of 2b. So I can say then that sine of 2b would be equal to cosine 90 minus 2b. And that's also Interesting because I also know this trigonomic identity that it's equal to cosine of 4a as well. So now I'm just going to substitute this cosine of 4a in here, do dt. And you see now I have it equal to cosine and cosine, so I'll be nicely able to cancel, divide each side by cosine, do, cancel. Then we have 4a is equal to 90 minus 2b. And earlier I found what b was equal to, so we can substitute that in here. And then we can say that 4a is equal to 90 minus 2 multiplied by 37 minus a. Running out of space. I'm going to move this over here so you guys can all see my amazing work. So that's going to be that 4a is equal to 90. 2 times 37 is 74. Minus 74. And then it's negative 2 times negative a. So that's going to be positive 2a. So then we'll get that 2a is equal to 16. And then divide each side by a, and we get that a is equal to 8. Amazing trig problem. And I think you should feel definitely comfortable solving these type of problems for December. And just friendly reminder, you want to really know these trig identities for the exam so that you can solve all trig problems sound and safely, safe and sound. Okay, so next up, this is a very interesting problem. It's a bit mixed with geometry, but also algebra. So let's take a look. So it says in triangle XYZ, the measure of angle X is X degrees, the measure of angle Y is Y degrees, and the measure of angle Z is 31 degrees. X is greater than Y is greater than 31. Which of the following additional pieces of information is not sufficient to determine the values of X and Y? Okay, so if we were to determine the values of X and Y, knowing that it's a triangle consisting of 180 degrees, we can say that X plus Y plus our angle Z, which is 31 degrees, is equal to 180. So in this case, I can see that X plus Y is going to be equal to 149 degrees. Okay, so if I want to determine if the other pieces of information will give me like individual values of X and Y, there is a simple way that we can determine this because basically I'm looking for the answer choice that is going to basically be the same expression as this, because that would be something that would be not sufficient to determine its values. And a really quick way to check this when you're dealing with these problems is to look at the coefficients in front of each of our values, because I can see that they're all the same. We can see that all of these are 31 and checking the coefficients in front. So let's make a little like table here. So I see X and Y, the coefficients in front of X and Y. So here it's just going to be -1 and -3. Okay, so interesting. Here we can see that it's +3 and +1. For option C, we can see that it's -3 and +3. And option D, it's going to be -3 and -3. So if the coefficients in front are going to be the same, that means that it's not going to give me any new information. So I know that's going to be option D. And just to show we can factor out the -3 here, which would be the same as X plus Y. Right? This would be 3X and this would be -3Y. Okay, so that won't give me individual values for X and Y. And if that's not clear enough, we can also just demonstrate this. So option A, for example, it's 31 minus X minus 3Y. We know X plus Y must sum to 149. So let's just hypothetically say there's a case where X equals 100 and Y equals 49. I can substitute 31 minus 100 minus 3 times 49. And that's going to be equal to negative 216. So I get a value. I can also say like X is equal to 90, and we'll say y is equal to 59. And if I do that, I will also get a unique value, which would be equal to negative 236. So the point is when I plug these in, I'm getting unique values depending on what x and y are. However, let's take a look if I do that with D, the correct choice, which would be same pairs I'm going to use, the x equals 100, x equals 90, 50. You're going to see that I'm going to get the same answer no matter what the values that I plug in are, because this would be 3 times 100 minus 3 times 49. Notice when I sum these, this is equal to negative 416. If I said that x was equal to 90, so we do 3 times 90 minus y being 3 times 59. Guess what's going to happen? Oh my goodness, it's going to be always going to give me the same value, showing that there is no change occurring. So that's how I know for sure that it's not sufficient to determine independent values of x and y. Hopefully that makes sense. So let's continue on our journey. Okay, so now this one, which expression is a factor of y squared, x minus 3 minus 25, x minus 3 cubed? Okay, so we could break this down further just because for sure I can see that x minus 3 is going to be a factor. But since we have it multiple times, we can simplify this further. So we can actually factor out one of the x minus 3s. Let's go ahead and do that. And then that would leave me with y squared minus 25 multiplied by x minus 3 squared. Okay, so then if we look at this as like a whole separate expression, we can take that a step further. Actually, even this we could bring down a little bit. So I do x minus 3 is y squared, and then that would be basically the same as minus 5, like x minus 3, and then squared. And then here we have a difference of squares. This is like a, well, think of this as like a squared minus b squared type of relationship, which always simplifies to a plus b, a minus b. So then doing that factorization would be x minus 3, and then we'd have y minus 5, x minus 3 for like our a term, multiplied by y plus 5x minus 3. So I've factored it fully, so I can see that factors that would work would be like x minus 3, y minus 5x minus 3, and then y plus 5x minus 3 would also be viable factors. And also we can see like if I do distribute this here, this would look like y plus 5x minus 15, which is y. The answer choice would be correct choice D. However, I know students don't love factoring, so let's see how we could place this on Desmos. So moving to Desmos, so same thing, like what I would want to do basically is to put the graph here. So we do y squared, and then I do x minus 3 minus 25. Then we have x minus 3 cubed. And then I set it equal to 0. And then I can see it gives me these different, well, looks like 3 different lines. We can see the y-intercept here is at 0, 15, 3, 0, and 0, negative 15. But if it's going to be a factor of the expression, it should cross one of the lines when I type them in. So option A, you can see when I do that, it's equal to 0. It does cross this line, but it needs to, but also goes here, meaning that this horizontal line at 0, that's not a factor of the expression. So this one is, but y equals 0 is not. So we can eliminate a. If we type in option B, that'd be x minus 5 multiplied by x minus 3, which again, we already know that x minus 3 is a factor, but x minus 5 is not. So I need it to be correct for the entire case when I type it in. So option C would be x minus 3 equals 0. We can see that's totally incorrect. And let's see what our correct answer choice D looks like. Y plus 5x minus 15 equals 0. Oh, look, it crosses amazingly through this line, and that's how I know for sure that I have it correct. So you can also see it quite simply when you type it into Desmos, but if you love factoring, you can also factor it like we did here, continuing our journey. So this one, I know I've done similar ones to this in the past, but it's very common, and I think you could see something similar on December. So it says, in a set of 4 consecutive odd integers, where the integers are ordered from least to greatest, the first integer is represented by x. Okay. The product of, okay, so 4 consecutive odd integers, how I would describe it as x, and x plus 2, and then we'd have x plus 4, and then x plus 6. And imagine why that is, because if this was, let's say, 1, then this would be 1 plus 2, 3, then this would be 1 plus 4, 5. So you can see they're consecutive odd integers. Okay, so it says the product of 23 and the third odd integer. So 23 times the third odd integer, which is x plus 4. And the set is at most would be less than or equal to 40 less than the sum of the first and fourth odd integer. So our first would be x, our fourth integer would be plus x plus 6. It's 40 less, so then we would subtract 40 from this. Okay, and then I just need to go ahead and solve algebraically. So this would be 23x plus 92 is less than or equal to 2x plus 6 minus 40. And then we'll bring like 21x over. We'll bring also subtract the 92 from the other side. So we get that 21x is less than 126. Divide each side by 21. And we'll get that x is less than or equal to negative 6. Careful, it asks you for what is the greatest possible value of x. Remember that x is a odd integer. So the trap answer would be negative 6. The greatest possible answer would be the next one down. That's odd, negative 7. Wasn't that such an amazing problem? Okay, continuing our journey. So this one, we have an equation, x over 7 plus y over 9 is equal to 41/63. An engineer connects resistors in series where the resistors in the series have a total resistance of 41/63 ohms. In the series, there are x resistors of type A, which each have a resistance of A ohms, and Y resistors of type B, which each have a resistance of B ohms. The given equation represents a situation. According to this equation, what is the positive difference between the values of A and the value of B? Okay, so the resistors, X resistors of type A, so imagine if we multiplied X resistors by type A, that's going to be equal to, according to this equation, x divided by 7. So just to show, if I multiply each side by 7 is equal to x, I can cancel x from each side. So I would get that 7a is equal to 1 because x divided by x is 1. And then we have that a is equal to 1/7. Likewise, there's y resistors of type B. So like y times b would be equal to y over 9. Multiply each side by 9. Divide each side by y. Y divided by y is also 1. And b is equal to 1/9. And then we already have our values for a and b, and we're asked for the positive difference, aka the absolute value between a, 1/7, minus 1/9, And when we solve, just to show, well, that would be like 9/63 minus 7/63, which is going to reduce to 2/63. And looking at the answer choices, looks like correct choice, D, 2/63. Amazing. Okay, so next concept up that I believe you should feel really comfortable with, for sure going to see percentages and some capacity on the exam. So let's take a look at the two problems you want to feel really comfortable with. Okay, this one. In 2013, Olivia earned 11% more than in 2012, and in 2014, Olivia earned 6% more than in 2013. If Olivia earned y times as much as 2012 as in 2014, which of the following is closest to the value of y? For this, we can solve algebraically, but also would be simple enough just to use units of 100. So we're going to say in 2012, her starting value is at 100. So in 2013, she earned 11% more than 2012. So that would be 11% more. We would do like 1 plus 11% or 1.11, which is going to be equal to 111. And in 2014, Olivia earned 6% more than 2013. 6% more than 2013, she earned 111. 6% more would be 1 plus 6%, aka 1.06. And when we multiply that, that is going to give me 117.66. Okay. And then it says, if Olivia earned y times as much in 2012 as 2014. Okay, so imagine like Olivia's 2012 earnings is equal to y times as much as in 2014. So y times 2014 earnings. Okay, so we know that y, or not y, 2012, she earned 100. And we know that in 2014, it was 117.66. And I'm trying to find what's closest to the value of y. So we just divide each side by 117.66. And when we do that, I'm going to get that it's close to 0.8499 will be equal to y. And that's why the answer is C. Amazing. Okay, so let's also look at another one. Oh, SAT classic. So a researcher investigated two species of mites, a predator and its prey. At the start of a week, there was an equal number of two species. Okay. At the end of the week, the number of prey had increased by 1,900 of the prey at the start of the week, and the number of predators had increased by 150% of the number of predators at the start of the week. The number of prey at the end of the week was what percent greater than the number? Okay, so again, just like the previous one, let's just say the start for predators was 100, which is equal to the start of prey, which we're also going to put at 100. But then at the end of the week, so end of the week, prey increased by 900. So if it increased by 1900, we would do 100 multiplied by 1 plus 1900 over 100. We multiply this, so basically 100 times 20, which is going to be 2000. So prey increased by to 2000 by the end of the week. And for predators at the end of the week, if it increased by 150, that would be like 150, 1 plus 1.5, which will be 100 times 2.5, aka increases to 250 by the end of the week. Okay, so now we have those values, and whenever you're asked on the SAT, like was P% greater than the number of predators at the end of the week, you can use the percent change formula, which is going to be, well, your formula is new minus original divided by original times 100, which that would be 2000 minus 250 over 250. This is going to be 1750 over 250. So basically 175 divided by 25, which will be 7. and then we multiply by 100. So it's going to be 700% greater, and 700 would be our answer. So just be really comfortable with percent problems like this. I feel you'll see similar ones on the exam. Next up, absolute value. Just know absolute value really well. Check out my other videos on absolute value if you haven't. But whenever you have something like this, like how many solutions does a given equation have? When anything is an absolute value and it's equal to a negative value, that's impossible. There's going to be zero values because if it's an absolute value, there needs to be a positive output. If it's ever equal to a negative value, it will be for sure no solutions. So remember that for the exam. SAT hints. And then let's talk about statistics, in particular standard deviation. Okay, so here we can see the standard deviation of set X is Q. Okay. And the standard deviation of set Y is S. Which of the following statements is true about the standard deviation or about the standard deviation of the data sets is true? Okay, so for this one, I always tell students for standard deviation, it's measuring in particular each data set or each number in the set, how close it is to the average. So if there's a low spread between or like a low distance between the mean, the standard deviation is going to be smaller. If there's a higher spread between the numbers, standard deviation is going to be higher. This one, I mean, to be honest, the numbers are pretty close because like if the average is like approximately around here, like 9, this is like 1 away from 9, this is 1 away, this is 2 away. And if the average here is like 3, this is also 1 away, 2 away. So it's pretty close and it's hard to really see when the numbers are this close. So guess what we get to do? Yes, that's right. We are going to go into Desmos and make our lives easier for the standard deviation problem. Okay, so let's go ahead and do that. Okay, so pivoting, sharing my screen. Okay, so okay, so what I'm going to do is I'm just typing in X. Do not type in X like this because it reads X and Y. Just type in X or set X. Or I could just call it Q. Doesn't matter what letter it is. And then I'm going to use these brackets to indicate that I'm creating a list of numbers. So here we have 7, 7, 8, 8, 9, 10, 10, 10, and 11, 11, 11. Oh, a 10 element list. Interesting. Okay. But what do I want to do? I want to find what the standard deviation of that list is. So you can punch it in if you want to. Or here, what you would do is go to the functions here and you scroll down to statistics, and statistics would be STDEV, standard deviation. I'm just going to put a Q. And look at that, it reads it right away. And now I'm going to put data set X in, or sorry, data set Y, but it said standard deviation would be equal to S. So I'm going to put in, just like we did before, use my little brackets here and type in 1, 1, 2, 2, 3, 4, 4, 5, 5, and 5. And then close brackets. Again, I'm going to go to my functions, scroll down to statistics, get standard deviation, and then I put in S, and then I can see the standard deviation of S is greater than Q. And that's why the answer would be correct choice C. My goodness, wasn't that so amazing? And that is the answer. Okay. So know what standard deviation measures. It does measure how spread out each number in the set is to the average or mean. But when the numbers are so close like this, I like to personally put them into the calculator and see what it will be equal to. Let's look at another one. let's see. So here, in each of the following data sets of 5 values, P is constant, which of these sets has the largest standard deviation? So it's going to have the larger spread of numbers. I can see it's going to be D. D creates the most variation in spread of numbers. But how to see that, like, how to see it more if you're new to standard deviation. So let's just say, I'm going to say that P is equal to 5 for all of these. So then I would just, you can pick any number for P. This is just to show this, the dispersion. So if that were true, this would be like 1, and then this would be 5, 5, 5, and then this would be 9. So a little bit of dispersion, but there's a lot of numbers that are really close together here in the middle. B, that would be 4, 4, 5, and then 6, 6. This is a really low standard deviation. The numbers are 1 away from each other. P would just be 5, 5, 5, 5, 5, which is 0. It has no standard deviation. If all the numbers are the same in the set, there is no deviation. It's just 0. And then let's check in our winner D, which this would be 0, then 1, then 5, but then we have 9 and then 10. And this dispersion, like the average is going to be somewhere in between here, right? But the dispersion from them, it's the greatest. They're more spread out than the other sets A, B, and C. And that's how I know for sure that our winner will be option D. However, if you didn't believe me, you could definitely go to Desmos and type it in like we just did here. In fact, I have done that for this one here. So just so you see, I just labeled them A, B for our sets here. A, B, and C. You see for A, standard deviation is 2.5. For set B, it's around 0.89. As I said, for C, it's 0. And here, standard deviation is 4.04. So standard deviation of D, it's the highest. You could choose any number for P. You'll still get the same standard deviation for each of them. Okay? So important concept. Make sure you know that for the exam. Okay, so guys, those are my must-know SAT math predictions for December 2025 SAT. If you like this video, please comment, like, rate, subscribe. It really does help, and I can continue to keep making amazing content. Sorry I was MIA for the past couple of months. It was just really busy, high season with SAT, GMAT, GRE, college applications. You know how it is. So I am back for you guys and I'm here. So message me if you have any comments. Tell me like the video, ask me questions. I love to engage with you guys. And I will be releasing more predictions this week. So thank you so much for watching. See you in the next video and talk soon. Bye, guys.